Welcome, everyone. We are watching the initial steps of setting up a mini hydroelectric station. The concrete foundation is precast. Here's a close-up of the system's heart. The Pelton water turbine. The conical injector is aimed straight at the buckets. The materials are ready. Pay attention to this thick-walled HDPE pipe designed for extremely high pressure. The technical team is moving the turbine housing. The thick carbon steel casing is being carried manually. It's not light at all. They position the turbine housing to fit precisely over the discharge trench on the concrete foundation and tighten the anchor bolts to secure it. Next is welding the flow guide pipe assembly to the turbine housing, securing the flange with a battery-powered impact wrench. The tightening torque must be even so the gasket doesn't leak. This is a highly valuable technical detail, a mesh-wrapped stainless steel flexible joint to absorb vibrations from the turbine. Tightening the flange of the flexible joint. Specialized tools make the operation extremely fast and accurate. Starting to process the penstock. A mini chainsaw is used to cut the HDPE pipe cleanly. Cleaning and removing rust from the flange of the large gate valve. This valve will control the flow rate. Setting up a specialized thermal butt welding machine for HDPE pipes. The pipe is securely clamped onto the hydraulic frame. Trimming the excess pipe. The cut surface must be absolutely perpendicular before heating. Another chainsaw cut to shape the pipe section. This section will be ready to connect to the gate valve assembly. The rough cut surface still has a lot of plastic burrs and needs reprocessing to ensure the thermal weld's quality. This is the facing step. The high-speed milling blade shaves off a layer of plastic, creating two perfectly flat surfaces. Looking at the extruded plastic shavings, the blade is very sharp. The virgin plastic quality of this HDPE pipe is excellent. A perfect surface. The Teflon-coated heating plate is inserted in the middle. The standard temperature is around 210 to 220 degrees Celsius. Pressing the two pipe ends against the heating plate and waiting for them to melt. Then, removing the plate and pressing the weld tightly to create an even thermal bead. The HDPE penstock is pulled across the rocky terrain. This material has excellent flexibility and impact resistance. Connecting the pipe flange to the gate valve. The mechanical assembly of the water conduction system is basically complete. The Pelton turbine housing is ready to receive kinetic energy from the water flow. A close-up of the Pelton turbine housing. The concrete discharge trench is curved to optimize the water outflow, preventing back pressure. Let's head upstream to explore the water collection system. Taking advantage of the steep, natural, rocky terrain of the mountain, they have set up a small-scale weir to collect the flow. The technician is clearing the channel, removing debris and mud. The abundant natural water flow will be directed into a settling basin. Earth's gravity is the core energy source here. Water rushes loudly through the rugged rock crevices. The elevation difference, which is the hydraulic potential energy, will directly determine the generator's total output power. This is the pressure tank, also known as the sand settling basin. The spillway baffle helps retain mud, debris, and air bubbles, ensuring the cleanest water enters the penstock. The intake of the HD penstock is fully submerged in water. The massive volume of water continuously rushing down the pipe will convert into tremendous kinetic energy at the power station. Returning to the generator unit, the technician turns the hand wheel to open the gate valve. The purpose is to vent trapped air and check the actual pressure. The water jet starts shooting out of the conical injector. Absolutely impressive. The water pressure tears through the space. The massive hydrostatic head creates a reactive water jet with incredible kinetic energy. This powerful stream will directly strike the turbine blades. This continuous flushing is a mandatory technical procedure. It helps wash away dirt and gravel throughout the entire pipeline, preventing the risk of destroying the Pelton buckets when operating at high speed. Next is the smart electronic injector module. Through the remote's RF signal, the linear actuator advances the needle cone. This allows for precise adjustment of the jet's cross-section and the water flow rate. Striking the Pelton buckets, the drive shaft begins to spin rapidly. The vortex discharge trench system clears the tailwater flow extremely efficiently. Now it's time to move the ACT generator into position. The magnetic rotor and copper-wound stator assembly is very heavy, requiring physical strength and smooth coordination from the technicians. The technician aligns the generator base, tightening the anchor foundation nuts with a wrench to ensure absolute concentricity between the turbine shaft and the magnetic shaft. Close-up of the rigid flange coupling. The two cast steel flanges are being joined tightly together. The entire maximum torque from the turbine will be transmitted directly to the rotor through here, remotely activating the injector. The water jet shoots out and the shaft system accelerates rapidly. The forged steel flywheel helps maintain rotational inertia, stabilizing the frequency. Installing the central control electrical cabinet. A technician is arc welding to reinforce the base. The full penetration welds help eliminate mechanical vibrations when the machine runs at high load. Checking the voltage with a multimeter. The TrueREMS unit shows the frequency reaching a standard 50 Hz. The analog pressure gauge indicates a stable hydrostatic head. The alternating current is ready. And here is the beautiful result at night. The stilt house is brightly illuminated by lights. The entire lighting system is powered by the self-sufficient mini hydroelectric plant. A perfect off-grid renewable energy solution. Harnessing kinetic energy and returning water to the source, respecting nature to harvest sustainable green electricity. The design is truly satisfying to watch.